Hello everyone, we're going to take a look at one last nonlinear optimization model. This one is based on a version of the Markowitz portfolio model that you utilize to try and maximize return on a portfolio with a bunch of different asset groups on it. Often these are mutual funds, and you're looking at annual return over a number of years. So I will warn you that I banged my head against the wall for a little bit on this one too. I found that there's a typo here. So it says minimize R bar subject to a bunch of constraints, but actually we're going to want to maximize it. Because if you read up here, it says we want to maximize the expected return. And if you look at R bar, it's the expected return. So up here they're telling us to maximize, and down here they're telling us to minimize. But okay, so we've got the annual return on a bunch of years. Then we've got basically each group, and we want to write down the proportions in each group. Basically, to fill out the chart, we just want to copy each of the years. So if we get it in the same window, I don't know if we quite can. Yeah, it's a bit of a chore, but basically we're going to put 10.06, 17.64, and so on. So let me see if I can remember this first two. 10.06, 10.06. And then the next one was 17.64, and then 32.41, and 32.36, and then 33.44, and you get the idea. And these are actually all the values of the return rates per year. So R with a subscripted number is just indicating the average return based on that year in terms of what we're going to be investing. So these FS, IB, LG, LV, SG, and SV are basically what we're going to be using as our portfolio weights, and those are going to be the changing cells when we do the solver in the Excel spreadsheet. So just keep that in mind for now. And check your work. Great. So the next 4 rows or 5 rows are basically the exact same, and then the proportion weights all want to add up to 1. So for this last one, we just put 1 in front of each of them, and we want that to equal 1. That's one of our constraints. And then the next one is looking at the average. So our bar is just determined to be the average of each of the returns for the years. So again, we just divide by 5. And we want that to be equal. And then the constraint for this problem, so the problem they did in the book was requiring some specific return, but this one, the main constraint is that the maximum variance is 30 down here in part A. So the maximum variance, this is basically the variance formula, but we have to divide by the number of proportion things we have. So we want that to be less than or equal to 30. And then we want all of our constants to be non-negative. So that should do the job for those. Now let me walk you through how to set up the spreadsheet. So I've already got mine set up, but basically if you click the data file, it will open Excel with this chart already in there for you. So it'll save you a little bit of time. And then, okay, so I've got the chart. And then what I did was I computed RI for each year. So how did I compute RI? Well, I did it exactly the way they did in the book. So first, I have the proportion to invest. I set up a bunch of dummy variables, so I didn't start them off this way. I started them off just so they would add up to 1, like 0.1, 0.1, 0.1, 0.1, 0.2, 0.2. Oh, I need 0.4. I need to add up to 1. Okay, so now they're adding up to 1. And then the RI, what I did is you multiply each proportion. So FS stands for foreign stock, so you do the FS, so B12 times B2, B13 times B3, B14 times B4, and so on down to R7, and you add them up, and that is the RI, or rather you take the sum of the proportions times these, and those give the weighted mean, or the expected value, which is giving you, in this case, R1, R2, R3, R4. And what you really want to do is you want to, remember, this is static, right? We're moving each of the columns over 1, so we want to fill to the right this column when you set it up. So basically, what I did was I computed this one, and then I filled to the right, and that's how I got the pattern. So Let's look at the formulas just so you can see those. So let's just look at B1 in particular. So B1, it's pretty long because you have a lot of them. You have B2 times B12, like I said, B3 times B13. And to make sure that these stay static, we have to put the dollar signs around each one of the FS, IB, LG, LV, SG, and SV proportions that we've got documented here. And then the expected return is going to be the average of all of these RIs. And then, okay, so if you try to follow the textbook and do it their way, they actually go through the by hand computation of doing variance, but, you know, why reinvent the wheel? We have a variance function in Excel, so if I go back to the formulas, I just did the variance of all the RIs, and that does the job for me. So when we do the solver, let's click the data ribbon, hit solver. What do we want to do? Well, we want to maximize the expected return. So if you hit minimize, like they say in the outline of the problem, you'll get it wrong. And then the constraints. Well, I put these ones in here. It might not be necessary, but I just basically wanted to make sure all of these were non-negative. Then I added a constraint that B18 has to equal 1. So this B18 cell is just the sum of all the proportions. I want to make sure that's exactly 1. And then B22, the variance down here, I want to make sure that's less than or equal to 30. And the cells I want to change are B12 through B17. So we want nonlinear. Go ahead and solve it. So we found a good solution. And what do we get? 13.267, all these guys. Variance is pretty close. So let me just enter the, I don't know the first one, and let's make sure we got that right. So what do we get? 13.27 says decimal places. So check your work. Hopefully we get it. No. What went wrong? 2 decimal places. I know this works because I just had it marked right. So what happened? 292. 13 point. Let me make sure everything's set up okay. The variance. Let me put these all kind of smaller, 0.15, just to reinitialize. So it's 0.6, so that'll be 0.8, not 0.8. That should be 1. Okay, so let me try to solve it again from here. Sometimes if the numbers are too high, it doesn't quite work out, or it's just a little bit off. Okay, this looks okay to me, so let me try it again. Okay, see, it just slightly changed, 13.3, and I bet that's what the computer wants, so my values were just slightly off. So let's see if 0.30 works. I know it's something around here. Sorry, this is weird. I was having this problem earlier today. I know these are basically right. They're just off by like a small margin of error. Let me enter them and see, because I bet the zeros are correct. So if I put 0 in the bottom 2, 0, 0. Let's see if 0.29. Oh, no, that's right, because it's as a percentage. So let me see if any of these other ones work. 29.83, 7.34, and 49.54. Somehow they feel a little bit off, but I know probably the zeros it got correct. Yeah, so the only one that's matching right now are the zeros. So let me pause this real quick and I'll make sure, I'll see what the problem is, and I'll start it right back up. Alright, so I figured it out. That's all we want to do when we do the solver is the best way. I was getting very close to the right answer. It's just you want to initialize them all to 0. I thought that might cause a problem because the sum was not identically 1, but Again, just set them all to 0, then run the solver, and we get the correct values: 13.28, 49.55. So you can see that was the previous one. It was very close. I'll check this again just to show that it works. Oh, did I not round correctly? Okay, it should be 49.56. You got to round the next one up. Or it looks like it should be 49.55. 7.35. See, all of these are off by at most 1. It's just very... This is either a 5 or a 6. But, okay, so you just have to toy with the values. Okay, 49.56. Okay, so it was just rounded slightly by a tenth, but it's very sensitive apparently. So this was 29.82. So very close, you know, on the assignment. I would give you credit for that. But anyway, that's it. The only difference on the last problem, I'll just give you a hint. We're not minimizing a variance. We actually need to calculate the mean of the squares of all the deviations with the S&P 500. So basically, you'll use the same exact chart. It's the same information. You'll just create there's an S&P column below. So you'll create RI again, create another row with their differences, and then square the differences, add up those square sums, and then you want to minimize that cell rather than variance. Okay, so hopefully that helps. And good luck on the assignment.